that's why, in this case, yes, it seems like we could have just said x equals 5 and be done with it. But the decision to do this is more important than the actual result because the precondition may not be as simple as just true. Yep.
Why do we have to, after post 1, why do you have to write forget t actually?
Because pre-1 is t.
Okay.
Because pre-1 is true. So from this step to this step here, I should use the mouse pointer so that people watching it can see it too. It's because pre-1 expands to t. So that's what leads from one step to the next. I'm taking very small steps every single time to maximize the chances of getting partial credit. Yep.
We have to include t in the end.
No, you do not have to. If you simplify it, that's good. Okay. So in this case, you can do the simplification, and if you simplify it to x equals 5, that's good. Okay. All I'm trying to say is, I don't want people to kind of think that they have to understand Boolean algebra because true and anything is anything. It's kind of like a Boolean algebra topic, which is not really the focus of what we're doing here. Even though it is important in the end, I cannot assume people can do that. Yeah. Okay, are we okay so far? So the next step is to link the post condition of line 1 to the precondition of line 2. Now, you would say, but that's really obvious. I mean, these lines are right next to each other, so the post condition of one should become the precondition of the other one. Just say something about it, okay? Give me an excuse to give you partial credit. So you want to say pre2 equals to post 1 because they are in a sequence, okay? Because there are times where line 2 and line 1 are not related by a sequence, okay? Because line 2 can be inside a conditional statement, and line 1 is the beginning of the conditional statement. So in that case, you cannot say pre2 equals post 1 because the concept of being in a sequence does not apply in that case. So this is kind of significant because in this case we can do it only because they're in a sequence. Okay, any questions so far? Nope. Okay, so we'll go ahead and try to derive post 2. So the same thing. The right-hand side of line 2 does not refer to the left-hand side. Okay, so once again, if you have a key, you can just say, refer to point A, or point A applies to line 2, something along that line. So that way I can see, okay, the reason, you just don't have time to write the entire thing out. So once again, we have to use the forget rule. Okay, so the forget rule, same thing. Post 2 equals to forget pre2. And this time, what are we forgetting? We are forgetting components that have y. Because y is the left-hand side of the assignment statement on line 2. That's why we are forgetting components that mentions y. Okay, it is important because if someone just copies and pastes, from the previous one, it won't work. And on top of that, we also know that y equals x plus 1 at this point, don't we? Okay, so this step on its own is already worth some points. The next step is to expand it. In other words, instead of saying pre2, I want to expand pre2 to become, well, we can spell out the whole thing, or if you did not simplify, we spell out the whole thing. If you did simplify, then we can just say it is x equals 5. Okay, are we okay so far? Okay. Then we can apply the actual forget operation. Does t mentions anything about y? Does true mentions anything about y? No. Does x equals 5 mention anything about y? No. So is there anything to actually forget? Nope. So we keep the entire thing, so it becomes true and x equals 5. But on top of that, we also know y equals x plus 1. Yep. You can do that. You can infer that, right? Yes. So you can basically say true. If you really want to simplify it, you can say x equals 5 and y equals 6. but you do not have to. In other words, I don't want people to think that they have to simplify and infer the actual value of a variable. Keeping it this way will already receive full credit, even though the end result of doing that is not as good as the one using the one that makes the fact y equals 6 explicit. Yep.
Why don't we say forget in front of the second line of the bottom?
You mean this line here?
Yeah.
Because this is the result of applying the forget operation.
Okay.
There's really nothing to forget. So we get to preserve the entire pre2 after the forget operation because nothing in pre2 refers to y. Okay? So every step, illustrates something about, how much do you understand and can you apply, these rules? Because these rules, there's a reason why it is like that. I just deleted the other part because the other part is optional. Okay, it's good to have it, but you don't need to have it. Okay. Well, I'll just put it in parentheses. No, that's not what I want to do. I can only undo one step at a time. Or not. Okay, I'll put this part in parentheses or in square bracket parentheses to indicate that if you want to go that far, that's fine. It is good that you know how to, push it to the fact that you know that y equals to 6. But if you don't want to push it, this one here will already give you full credit. Okay? Okay, so now we are moving on to line 3. Yes?
Whenever the right-hand side is equal to the left-hand side, do you use the forget operator?
Yes, the only time you can use the substitution rule is when the right-hand side is a reversible operation. Now, if you look at line 1, it is not reversible. In other words, after line 1, I know for sure that x equals to 5, but there's no way for me to start with the fact that x equals 5 to reverse back and say, but what was the value of x before this line? There's no way for me to reverse it, and that's why the substitution rule cannot apply. Okay? So the substitution rule requires a lot of prerequisite before you can apply it. And anytime you cannot apply the substitution rule, you have to use the forget rule. Is that okay so far? Okay. So the next one is the same thing. The right-hand side of line 3 does not refer to the left-hand side. Same thing. So once again, we have to use the forget rule.
Would you want us to do pre-3?
Oh, yeah. Thank you. So pre-3 equals to post-2 because they're in a sequence. Okay, because they are in a sequence. So once again, you can say refer to point A or something like that. C point A. C point B, C point C. Okay, so this one pretty much the same thing. We say post 3 is the result of applying the forget operation on pre 3. And this time, what are we forgetting? What components, or components including which variable? Including x. Very good. But after that, we know one thing. We know x equals to 3 after this operation. So in this case, you just have to copy your pre-3. Now, this is the important part. If you state that pre-3 or post-2 is this is what you need to copy and paste. If you state that pre-3 or post-2 or pre-3 is this one, that's the one you have to use. In other words, within the answer itself, it has to be self-consistent. Okay? So self-consistency is very important because I don't want anyone to jump to a certain step. Suddenly you mentioned that pre-3 is this, but I don't see that anywhere else in your derivation. That would not be good. So then you just expand. Whichever one you want to use is fine. Okay, I'm not going to rely on people. I'm not going to count on people being able to do the Boolean algebra thing and derive more specific answers. So just copy and pasting the whole thing is fine. Okay, just like that. So according to this, t does not mention anything about x, but x equals 5 does mention something about x. Y equals to x plus 1 also mentions something about x. So according to this, it will become t and x equals 3. I basically have to forget just about everything in the precondition of line 3. Yep.
Why would you forget y?
Yep, because in this case, I did not make it explicit, and that's why I have to forget it. So if you did it your way, then you would have kept y equals 6, because you have just decoupled y from the value of x when you state that y equals 6. But I didn't teach that in the class. I did not teach you guys to try to decouple the value of a variable from other variables. So that means that I cannot count on you guys knowing how to apply that, which means that if you just give me this answer, it is just as good, because according to this, the application of the forget operation is exactly what it should be doing, because we are forgetting all the components that mentions anything about x. Yep.
So if I go with the other one where it's x equals 5 and y equals 6, I would add the y equals 6 then?
Yes, correct. If I, yep, exactly. In other words, I'll be looking at, what you're putting inside the forget and the result of the forget. As long as that is consistent, I have evidence to show that you know how to use the forget operation. Okay. In other words, if you make a simple mistake, early on, and your precondition is cascading the wrong ones, but as long as your forget operations are still consistent, you will still get partial credit for all those. Okay. Any questions at this point? Now, this is the last one. The last one is, pre-4 equals to post-3, because they are in a sequence. Okay, so if you want to be, if you want to save a lot of writing, you can use the because notation in math. Do you still remember, how do you write the because in mathematics? It's the 3 dots. But I can't remember, is it the regular triangle, or is it the inverted triangle? So it's the regular one. Do you guys know the HTML code for that symbol? Okay, how about this? I let you guys use this. Because, BC. So I can say because. You don't even have to use, full English. Just mentioning the word sequential is good. Or if you prefer, that is good too. As long as I know what you are trying to say, it is good. Okay?
Wait a second. Did you forget the y equals x plus?
No, I did not forget it. Well, yes, I forgot it, because that's the point of the forget operation.
Oh, right.
Because, I'm trying to forget all the components that mentions x. X equals 5 mentions x, and y equals x plus 1 also mentions x.
So you forget the
That's why I have to toss it. Yep. Now, if I did one extra step and concludes that y does equal to 6 at that point, instead of relating y and x, then I would have kept y equals 6, because y equals 6 does not mention anything about x. But since I did not talk about that, I did not talk about how to decouple a variable from another variable, I cannot assume that you guys can do it. And if I cannot assume you guys can do it, I'll just take the baseline, which is, this part here.
And then on that, if we did do it x equals 5 and y equals 6, we could forget to put the t. We wouldn't have to carry
The t should be simplified way earlier. In other words, if you want to simplify out the t, it should be simplified in this step. So the optional step here is to say just, x equals 5 here. Because true and anything is anything, so the simplification would have, should have been done like way, way, way earlier. But if you did not and just, syntactically apply the forget operation, that's fine, because that's